Welcome, welcome, welcome to the first episode of Matlab Basics. In this video, I'm going to be talking about what Matlab is as a program, how it differs compared to other languages, and then introducing the user interface. For those of you not familiar with Matlab, Matlab is a scripting language. It is comparable in functionality to R or Python, and in fact there's an open source version of it called Octave. Matlab recently was shown to be one of the most dreaded languages for programmers to face, compared to alternatives like Python, which are considered beloved. So I'd like to spend a little bit of time today going over what I think distinguishes Matlab and how to use it. So in front of us we have the standard video display. You can see here I've docked a window, so we have an editor region here in the center of the screen. On the right hand side we have the current workspace. We have a command window where we're able to manually enter code, and we have a current folder view. So Matlab in some sense has a bit of an unusual memory structure. Compared to many languages which have each program having their own variable workspace, Matlab actually has a global workspace and then a number of functional workspaces. So to illustrate how this works, we're going to start by making a simple script. So scripts, like the one I'm about to enter in the editor, essentially always run in the global workspace. And the normal way of working for me personally is to have a script call other functions as I need them. So for example, you might start a script with a set of commands like clear all and close all. Let's go ahead and save this file, example1.m. So the first line will clear the global workspace, and the idea is that I want to make sure that I'm always starting from a clear baseline. The command close all will remove any opened windows. The result of this is these two commands together will reverse, I would say, about 90% of changes Matlab might have. This makes things like debugging easier because I'll always be starting from the same location. So if we want to have a really simple test program to explore these ideas a little bit, I'm going to go ahead and add a command like display this in quotations. So you'll notice this is underlined, and the reason that it's underlined is that I haven't put a semicolon after it. Languages like Python don't require semicolons. Languages like C++ require one at the end of each command. In Matlab, actually, you have the choice of whether you want to put one there or not. The difference between the two is without the semicolon, the output of that command is displayed. And that's what it's warning about here. So here it's warning us, it says terminate statement with semicolon to suppress output within a script. So let's see exactly what happens. So I'm going to use some hotkeys here. So option number 1, if I want to run a piece of code, is to hit F5. If I hit F5, you see in the command window we get a little bit of text. It says example1, that is the command I ran, because every script can be run directly as a command, and I get answer equals display this. Answer being the default value. So whenever a command is run and its output isn't assigned to anything, it's put into a variable called answer, A-N-S. And you can see it's now been placed in the workspace, display this. So conversely, if I silence the output, and again I hit F5, you'll note it's still populated in the workspace. So the variable is created regardless of whether or not it's displayed on screen. And you can see here that this time we didn't display something on screen. Of course, if you want to actually display things on screen, it's better not to use a format like this. Much better to use a command like fprintf. So this is using the same syntax that you would see in, for example, a C program. So fprintf will print to the current display. There's a lot of other ways to print to screen. This is just my personal favorite. So again, I hit F5, and you'll see this time it said display this, but it didn't actually populate anything in the workspace, because this time I used a command for displaying a line of text. For those of you not familiar with C languages, the /n tells it to put a new line into place. Okay, so next up, let's explore a little bit of how variables work. So, for example, we might make a program like FizzBuzz. So, we can start out by making a for loop. So for I equals 1 to 10. So we now have a for loop. And just to give you an idea of what's happening here, let's go ahead and display the numbers as it runs through them. I hit F5 again to execute, and you see it displays the numbers 1 to 10. So we can make a conditional statement here, like if I equals 1, fprintf fizz, else if I equals 2, fprintf buzz. So you see when it hit 1, it hit fizz. When it went to 2, we hit buzz, and otherwise we didn't do anything. So one of the things that makes MATLAB particularly powerful is it has a built-in API which is incredibly extensive. So virtually anything you want to do in MATLAB, you can do in MATLAB. I have yet to find something that I was really stuck on. An example of some basic functionality that is present in pretty much every language, though, is the mod command. So for those of you not familiar with the FizzBuzz code, the idea is that you type fizz every time that you have a number divisible by 2, buzz every time you have a number divisible by 3, and fizzbuzz every time it's both. So let's take a look at the mod command. In the built-in help browser, we have the modulus after division. We have a definition here. So we're going to check if mod I divisible by 2, we're going to write fizz. If mod I divisible by 3, we're going to write buzz. So we'll start out with a simple program like that, but you'll note that actually things didn't work out quite right. So to see why, let's go ahead and display the number before we display fizz or buzz. And you can see that for example, 6 didn't correctly display both fizz and buzz. So let's clean up our outputs a little bit, take another look, and you can see indeed 1, 5, and 7, which are prime numbers, don't display anything. The others all do, but fizz is taking priority over buzz, when in fact for the numbers 6, we actually want to show fizzbuzz. So let's go ahead and fix that now. So we have if that, and now we want and not that. You notice I use the semicolon equal for does not equal. In other languages you might see exclamation mark equal instead for does not equal, but this is the convention here. So if it's divisible by 2 but not by 3, write out fizz. Otherwise, if it's divisible by 3, write out buzz. Now we have an issue here, which is what if it's divisible by both? So this else if statement needs to be adjusted. So let's go ahead and fix this. We can do this a couple different ways. So we know already that it's divisible by at least 3. So let's check if it's divisible by 2. We'll write fizzbuzz. Otherwise, we'll write buzz. Okay. So now it should work. Yeah, so we see fizz, buzz, fizz, nothing, fizz, buzz, nothing, fizz, buzz, fizz. And just to complete fizz, buzz, it should, strictly speaking, go to 100. So this is the final output. So this is a really basic example of the basics of MATLAB, how if statements, else statements, and for loops work. And this will get you a pretty long way in MATLAB. But just to give you an idea of why MATLAB is so convenient to use, I would say the main reason I like it is that things that in other languages take quite a bit of work are basically instantaneous in MATLAB. So let's say I was writing this in Python or something like that. I would have to sit down, remember which API I wanted to use for, say, displaying a figure of this. Whereas here, if I want to, for example, illustrate where fizz, buzz, and fizzbuzz happened, we can do that extremely easily. So let's create an array called value fizzbuzz, and we're going to populate it with zeros. The formatting here is I want 1 row and 100 columns. So we're going to set the value fizz as being equal to 1, the value buzz as being equal to 2, and the value fizzbuzz as being equal to 3. And now I want to display a figure that's going to have a plot of the numbers 1 to 100, fizzbuzz, and I want it to use x's. So if I generate this, I get a pop-up, which you currently can't see. There we go. There is our values. So anything where there was nothing set, which is essentially any number not divisible by 2 and 3, has value 0. Anything divisible by 2, so every odd number gets, every even number gets a value 1. And then anything divisible by 3 gets the value 2, and anything divisible by both picks them up. So for example, 6 is the first entry with value fizzbuzz. Now you can make this much cleaner. You can do basically anything you want with these figures, but we're going to hold off on making figures for another day. My point that I wanted to illustrate is that we can make simple, effective, and interesting software very quickly using MATLAB. And I hope that this has given you an introduction to the idea and left you with at least the tools to go out and try things. I will be posting future videos to this channel so that there will eventually be a basically complete course in how to program in MATLAB. And I hope that if you like this video, you will hit like, and if you want to see more of this stuff, please consider subscribing. Also, if you have questions, or if you think I didn't answer something appropriately, go ahead and leave a comment below, and I will answer it, and maybe update the video, or make improvements to future videos. So, this has been Coding Like Mad, and I will see you next time.